All right, so today we're going deep, really deep into the world of Stephen Hawking.
Oh, this should be good.
We've got some excerpts from his biography,
Okay.
and I think it's going to surprise some people.
Oh, yeah.
It's not just the brilliant mind in a wheelchair story that everybody knows.
Right.
Well, there's so much more to it. There are a lot of surprises in here.
I'm intrigued.
Yeah, so let's start at the very beginning. Hawking, he was born in Oxford, 1942.
Okay.
His family, interesting bunch. They were doctors, but not exactly wealthy.
Oh, interesting.
But you know what they were really into? Education.
Yeah.
Like big time. The biography even talks about how they'd have these silent meals
Yeah.
with everybody just like reading books.
Wow, what a picture.
Right. Talk about a recipe for a future physicist, right?
Yeah, I mean, you can almost see that book-filled dining room as the foundation for his, incredible curiosity.
Totally. And he wasn't always this straight A student.
Really?
Yeah. I mean, they called him Einstein at school, which is funny.
I mean, that's quite a nickname.
Yeah, but he wasn't like a standout student at first.
Huh.
But then there's the story about his Oxford entrance exams.
What?
He finishes early, thinks he's totally bombed it.
Oh, no.
And, get this, he tells the examiners, he says, if you award me a first, I will go to Cambridge.
Wow.
If I receive a second, I shall stay in Oxford, so I expect you will give me a first.
He just, told him what to do?
I know. Can you imagine the audacity?
That's incredible. And so Hawking...
Total confidence.
Yeah, but it wasn't just confidence. His tutor later said that the examiners knew they were dealing with someone way smarter than them.
Oh, really?
Yeah, they recognized a truly exceptional mind when they saw it.
Well, he got his first, of course.
Of course.
But then, comes this major turning point.
Oh, yeah.
At 21, while he's at Cambridge,
Uh-huh.
he gets this devastating diagnosis, motor neuron disease.
Oh, wow, yeah.
And the doctors initially give him just 2 years to live.
How do you even process that?
Yeah. Right. I mean, it's not just a medical diagnosis. It's like a confrontation with your own mortality.
Absolutely, and at such a young age.
Yeah, and this moment, it really becomes a catalyst for Hawking.
In what way?
It seems to ignite this, incredible sense of urgency in his work.
Right, suddenly every moment counts.
Exactly. I mean, there's a period of, understandable depression.
Of course.
But then something shifts. The disease progresses slower than expected.
Okay.
And he returns to his research, but with this, newfound intensity.
Fascinating.
And this is where things get really interesting. His reputation grows not just for his brilliance,
Yeah.
but for his, his boldness in challenging these established giants in the field.
Oh, you mean when he publicly questioned Fred Hoyle's steady-state theory?
Exactly. Hoyle, he was a leading astronomer.
Oh, yeah.
But Hawking, this young researcher, he just takes him on publicly.
Bold move.
Right. Poking holes in his theory. I mean, this wasn't just some friendly academic debate. It was a statement. It showed, the kind of intellectual fearlessness that Hawking would become known for.
Absolutely. And this fearlessness really comes through in his work on black holes.
Yeah.
Particularly his doctoral thesis. Groundbreaking stuff.
Okay, so break this down for me.
So he applied singularity theorems to the entire universe.
Singularity theorems, those sound intense.
Well, they are.
Okay, so for those of us who aren't, theoretical physicists.
Right.
What are we talking about here?
Okay, so imagine a point in space and time where gravity is so strong that it, warps everything, even light.
Okay.
The ultimate cosmic traffic jam where all the laws of physics as we know them, they just break down.
Mm-hmm.
That's a singularity.
Okay.
And what Hawking and Roger Penrose, his collaborator,
Right.
showed is that these singularities, they're not just theoretical quirks.
Oh, okay.
They're inevitable consequences of Einstein's theory of general relativity.
So these singularities where everything goes haywire, they're not just hypothetical?
Nope, they actually exist,
Wow.
at least according to our current understanding of physics.
Okay.
And here's the mind-blowing part. Hawking and Penrose, they didn't just apply this to black holes.
Yeah.
They applied it to the entire universe. They proposed that the universe itself began as a singularity.
Boy.
The Big Bang, a point of infinite density where all of space and time sprang forth.
Okay, yeah, I'm starting to see why this was groundbreaking.
Right.
He's essentially using these theorems to describe the birth of the universe.
Exactly.
But wait, so if the Big Bang was a singularity,
Yeah.
does that mean, the universe is also destined to end in a singularity?
That's a great question.
Like a giant black hole swallowing everything up?
And it's one that physicists are still grappling with today.
Oh, wow.
Hawking's work really opened up a whole new way of thinking about the universe's beginning and end.
So a lot to unpack here.
Definitely.
Basically, Hawking's arguing that these, mind-boggling singularities,
Yeah.
they're a fundamental part of the universe,
Right.
both at its beginning and in the heart of black holes.
Mm.
But how does this connect to his later work? The stuff he becomes even more famous for?
Ah, yes.
Like Hawking radiation. That always seems so mind-bending to me.
Well, that's where we really see Hawking pushing the boundaries of our understanding.
Okay.
But to get there, we need to delve a bit deeper into the mysteries of black holes themselves.
All right, lead the way. Let's go deeper down the rabbit hole.
Let's do it. So, black holes, right? Imagine them like, I guess, a cosmic drain.
Yeah, I always pictured them like giant vacuum cleaners in space.
That's a pretty common analogy, I guess.
Just sucking up anything that gets too close.
Right. But here's the thing.
Okay.
For a long time, black holes were thought to be these like completely isolated objects just sitting there swallowing matter and energy.
Okay.
But then Hawking, he comes along and he kind of throws a wrench into that whole idea.
This is where Hawking radiation comes in, right?
Exactly.
I'll be honest, the concept always seemed a little over my head.
Well, get ready, because it's pretty mind-blowing.
Right.
Hawking shows that black holes aren't actually completely black.
What?
Yeah, they actually emit this faint radiation.
They do.
Yeah, and it's due to these quantum effects happening at their edge, near the event horizon.
Hold on, so you're saying these cosmic monsters,
Right.
these ultimate sinks of like matter and energy, they're actually leaking something back into the universe.
Exactly. It's almost like discovering that a fire can create ice. You know what I mean?
Wow.
And this radiation, we call it Hawking radiation now, it carries away a tiny bit of the black hole's energy.
Okay.
And over incredibly long timescales, this could even cause the black hole to, shrink.
Shrink.
Yeah, and eventually evaporate completely.
Black holes can evaporate.
They can.
That totally changes how I picture them.
That's a game changer for sure.
So they're not just these eternal prisons, they're like slowly dissolving back into the universe.
In a way, yes.
But how does this even work? Doesn't that go against everything we thought we knew about black holes?
It all boils down to the weird world of quantum mechanics.
Ah, okay.
So at the edge of a black hole, at the event horizon,
Right.
things get a little fuzzy, shall we say?
Okay.
Quantum fluctuations create pairs of particles and antiparticles.
Okay.
Now, normally, these pairs would annihilate each other almost immediately.
All right.
But at the event horizon, something different can happen.
What's that?
One particle gets sucked into the black hole,
Oh, cool.
while the other one escapes.
And that's the Hawking radiation.
That escaping particle is what we observe as Hawking radiation.
So it's like these particle pairs are constantly popping in and out of existence near the black hole.
Yeah,
And sometimes one gets trapped and the other gets flung out into the universe.
exactly.
And that takes some energy with it.
It carries away a bit of energy, yeah.
That's incredible.
And because this radiation is carrying away energy,
Mhm.
it means the black hole itself is actually losing mass.
Oh, I see.
So over these incredibly long timescales, we're talking billions and billions of years.
Right.
Even a supermassive black hole could completely evaporate.
Because of this Hawking radiation.
Exactly.
Okay, my mind is officially blown.
That's a lot to take in.
This idea, it just flips our understanding of black holes on its head.
Totally.
So they're not just these eternal prisons, they're actually dynamic entities that can, dissolve over time.
Right.
But this raises a big question for me.
Oh, yeah.
If black holes can evaporate,
Yeah.
what happens to all the stuff they swallowed? Where does it go?
The million-dollar question. And it leads us to another one of Hawking's major contributions.
Okay.
The information paradox.
The information paradox.
So in the classical view of black holes, whatever falls in, it's gone.
Right, forever.
No information about it can escape.
Okay.
But, according to quantum mechanics,
Right.
information can never be truly destroyed.
So you're saying we have this conflict between general relativity, which says black holes gobble up information,
Yeah.
and quantum mechanics,
Yeah.
which says information can't be destroyed.
Exactly. It's a clash of titans.
That sounds like a recipe for a major headache.
You could say...
So how do we resolve this?
Well, that's the thing. This is the information paradox.
Right.
And it puzzled physicists for decades.
Really?
Even Hawking himself changed his mind about it over time.
He did.
At first, he believed that information was lost in black holes.
Okay.
But later on, he revised his view,
Oh, interesting.
suggesting that information might somehow be encoded in the Hawking radiation, leaking back out into the universe.
So the information isn't destroyed. It's
Yeah.
just, like, transformed.
It's transformed and released in a way that we don't fully understand yet.
Okay.
It's like, imagine trying to piece together a shredded document.
Okay.
The information's still there, but it's spread out, encoded in this complex way.
I see. So the information paradox is still, like, an unsolved mystery.
It's an active area of research, definitely. It's pushing the boundaries of our understanding of both quantum mechanics and gravity.
It's amazing to think that something as, I don't know, seemingly simple as a black hole
Right.
can lead to such profound questions about, like, the nature of reality
Totally.
and the fundamental laws of the universe.
It's really humbling, isn't it?
It is. But let's not forget that Hawking, he wasn't just interested in these, like, abstract concepts.
Yeah.
He also wanted to make these ideas accessible to, the public.
Absolutely.
And that's where I think his book, A Brief History of Time, comes in.
Oh, yeah, that was huge.
It wasn't just a book. It was like a cultural phenomenon.
It really was. And the story behind it is almost as interesting as the content itself.
Oh, how so?
Well, he wasn't initially trying to write a bestseller. You
Right.
know, his motivation was actually quite practical.
Oh, okay.
He needed money, to be honest,
For
to finance the mounting costs of his care and his children's education.
Oh, wow. So the book was, like, out of necessity.
In a way, yes. But of course, it ended up becoming this incredible success.
Yeah.
Staying on bestseller lists for years, introducing millions of people to the wonders of cosmology.
It's amazing to think that a book about black holes and the Big Bang
Yeah.
became, like, a global sensation.
It really speaks to his ability to capture people's imaginations
Right.
and make these complex ideas not just understandable, but like truly engaging.
Totally. But with that success came a level of fame that, few scientists ever experienced.
Oh, absolutely.
He became a pop culture icon, appearing on TV shows.
Yeah.
Lending his synthesized voice to documentaries, inspiring a biopic even.
He truly transcended academia
He did.
and became this global figure,
Yeah.
a symbol of intellectual curiosity and human resilience.
But I imagine that kind of fame, it wasn't always easy, especially with everything he was going through personally.
Right. You have to remember, behind the brilliant mind and the public persona
Yeah.
was a man facing the very real and relentless progression of his disease.
And that's something we shouldn't forget.
Absolutely not.
I mean, as much as we celebrate his intellectual achievements,
Yeah.
it's important to remember the human cost of his condition, the
Right.
constant need for care, the
Yeah.
adaptations, the gradual loss of his voice.
The challenges were immense.
And that's where the evolution of his communication technology becomes a story in itself.
Oh, for sure.
It started with a simple spelling card,
Right.
then a switch-activated speech synthesizer,
Yeah.
and eventually a system controlled by the tiniest movements of his cheek muscles.
Incredible, isn't it?
It's really remarkable. It speaks volumes about his determination to, like, not let his condition define him,
Yeah.
to keep pushing the boundaries of what was possible.
Absolutely.
It's also a testament to the power of technology.
Right.
To bridge the gap between mind and body.
To allow someone with such profound physical limitations
Yeah.
to continue to share his thoughts and insights with the world.
Exactly. But Hawking wasn't just a scientist, confined to the ivory tower.
Oh, no, not at all.
He had strong views on lots of things, politics, the future of humanity. He wasn't afraid to speak his mind.
He was very outspoken.
Yeah.
He was an atheist, a vocal advocate for disability rights.
Oh, right. Although I read that he had some, like, mixed feelings about being seen as a representative for the disabled community.
Yeah, he did. He wanted to be recognized for his work, not just his condition.
Which is understandable.
Absolutely.
But there's no denying that his life story, it became an inspiration for so many people
Oh, yeah.
facing their own challenges.
He showed the world that a debilitating condition
Right.
doesn't have to extinguish your intellectual curiosity.
Or the will to make a difference.
Exactly. But he also had some really interesting thoughts about the future of humanity, didn't he?
He did, and his views, I felt, were often kind of, like, tinged with both hope and caution.
In what way?
He saw huge potential in things like artificial intelligence and space exploration.
Right.
But he also warned about the dangers, if we don't approach them responsibly. And he was a big advocate for tackling climate change.
Yes, he was.
Making sure that humanity actually survives in the long run.
He was deeply concerned about the fate of our species.
So he wasn't just looking up at the stars, he was also looking at what was happening here on Earth.
Yeah, he saw science and technology as these powerful tools
Right.
capable of great good and great harm.
And his warnings, they're a reminder that we need to think critically about the implications of our discoveries,
Oh,
right?
sure.
To use our knowledge wisely.
Absolutely.
So a complex individual,
That point.
brilliant scientist, captivating communicator,
Yeah.
and a passionate advocate for the future of humanity.
He was all of that and more.
Yeah.
A true original, someone who defied limitations, challenged assumptions, and left an undeniable mark on the world.
We said at the start that there was more to Stephen Hawking than a brilliant mind in a wheelchair, and wow, there really is.
There's just so much to his story, right?
So much. I mean, we've gone from a childhood with all those books to like groundbreaking discoveries about black holes, the Big Bang.
And we saw how he wasn't afraid to challenge those big names in science.
Yeah, he really wasn't.
And of course, his resilience facing that diagnosis.
It's hard to even imagine.
And then he becomes this global icon.
Right, like a pop culture phenomenon.
And he made these complex scientific ideas make sense to millions of people.
Yeah, not just make sense to them, he got them excited about it.
He did. It's like he was this bridge between the vastness of the universe.
Yeah.
And like our human desire to figure out where we fit in, you know.
So where do we go from here? What's the message, the takeaway from all of this?
I think Hawking's life shows us that, like, our potential for understanding, for discovery, it's limitless.
It's inspiring, for sure.
He showed us that the human mind can tackle the biggest mysteries of the universe,
Yeah.
even while dealing with incredible challenges.
He never let his physical limitations define him, did he?
No, not at all. It almost felt like sometimes those limitations, like they pushed him even further to explore those boundaries of knowledge.
It all goes back to that curiosity, doesn't it?
Does that constant need to learn, to ask questions, never stop searching for answers,
It never left him, that childlike wonder.
even when he was dealing with the toughest stuff.
So what's Hawking's biggest legacy, his impact on future generations?
It's a good question.
Yeah.
I mean, obviously he revolutionized our understanding of black holes, the Big Bang,
Right.
space and time, all of that.
But beyond the science.
I think his biggest impact is his ability to inspire.
Inspire.
To inspire people to embrace curiosity, to challenge limitations,
Yeah.
to never stop trying to learn.
That's beautifully put. He showed us that even with unimaginable adversity, the human spirit can achieve amazing things.
Absolutely.
He reminded us that the universe is full of wonder, full of mystery.
And it's waiting for us to explore it.
So what would you say to someone who's heard this and feels inspired by Hawking's story?
Good question.
Someone who wants to learn more about all this, but maybe feels intimidated by the complexity of it all?
I'd say embrace that feeling of awe. Don't be afraid to ask questions, to challenge what you think you know,
Yeah.
and find resources that make these ideas easier to understand.
There are so many great books, documentaries out there now.
Oh yeah, lots of online resources too.
It's all at our fingertips.
And remember, even Hawking had to start somewhere, right?
He didn't just magically know all this stuff.
No, it was his curiosity, his willingness to learn, to keep asking questions. That's what led him to those discoveries.
So as we wrap up this deep dive into the incredible life and legacy of Stephen Hawking, let me leave you with this thought.
Okay.
If you could ask Stephen Hawking one question, what would it be?
What mystery of the universe would you want him to unravel?
Think about that. Hold on to your curiosity.
Let it guide you on your own journey of exploration.
Thanks for joining us on this incredible journey. Keep looking up and keep asking questions.